Hi guys, I'm Stark and today we are looking at the electromagnetic spectrum. So the electromagnetic spectrum is a continuous range of wavelengths. So the type of radiation that occur in different parts of the spectrum have different uses and dangers. This all depends on their wavelength and their frequency. So with bigger wavelengths, technically it is less dangerous. The smaller wavelengths you go, it becomes more dangerous. So with a wavelength of 1 kilometer, you have something like a radio, which of course, a radio wave, which of course is used for things like, well, a radio, obviously. Then you get a bit smaller. This is going in the middle of about 1 kilometer and 1 millimeter. And then you get microwave. So this is another thing. And this is used for microwaves, of course. And then you get at 1 millimeter, you get about, so you get infrared radiation. So infrared is all around us. Everyone has infrared, so it's not dangerous at all. Then you get visible, which is light, which is in between 1 millimeter and 1 nanometer. And a nanometer is 0.0000001 millimeters. Alright, and that is visible light you can see all around you. It's how you see things. So when you just look out, the sky is blue, that's visible light. Visible light, again, not dangerous. Then you get ultraviolet radiation. So ultraviolet radiation is dangerous and, well, it's quite dangerous. I mean, it's not really dangerous. It's used in sunbeds, for example, which of course can be dangerous. And that's got the wavelength of between 1 nanometer and 1 picometer. And then finally, X-ray radiation and gamma radiation, that is quite dangerous. It is used in X-rays, so of course you do have your X-rays and that isn't too dangerous. But if you have too many X-rays, that is dangerous for you. And that is 1 picometer. And if you remember I said 1 nanometer is 0.00001 millimeter. Well, 1 picometer is 0.001 nanometer. So it's tiny. You imagine how small a millimeter is. This wavelength is absolutely minuscule. So the way you work out the speed of electromagnetic waves is by velocity equals frequency over wavelength. Now, I would highly recommend you know that, and you can, of course, you can rearrange that to make things like wavelength is velocity divided by frequency, and frequency is velocity divided by wavelength. But you've got to remember that velocity is measured in speed in meters per second. Frequency is measured in hertz, which is Hz, and wavelength is measured in meters. So do remember that, that's very useful, and you can work out either thing, velocity, frequency, or wavelength. So thanks for watching. Please can you go to my website www.imstuck.wix.com/imstuck GCSE revision. Watch and subscribe, and my website, by the way, has loads of amazing quizzes. So go and do them and test how actually good you are. Let's say. All right. Thanks for watching and see you soon. Bye.